Seen from space, Earth is a beautiful blue sphere. Take away the clouds and you'll discover that 71% of the surface is covered by water. Looking a little closer, you'll see that just 3% is freshwater from lakes, glaciers, and ice caps. Of that 3%, just 0.25% comes from freshwater lakes, a mere 0.07% of all the water on the surface of Earth. From small fishing ponds to Great Lakes in North America, Africa, and Russia, freshwater lakes are precious resources that provide an important sense of place to people and communities. Observations indicate that our lakes are warming. A recent NASA study measuring surface temperatures of 167 inland lakes over 24 years from 1985 to 2009 indicated that 95% of the world's largest lakes have been steadily warming, some as much as 4 degrees Fahrenheit or 2.2 degrees Celsius. In some cases, the trend is twice as fast as the air temperature trend over the same period. Lake Baikal in Siberia is the world's largest, oldest, and deepest freshwater lake. Since the mid-1940s, the surface temperature of Lake Baikal has risen by 2.1 degrees Fahrenheit or 1.2 degrees Celsius. The Laurentian Great Lakes in North America, located along the border between the United States and Canada, consist of Lake Superior, Michigan, Huron, Erie, and Ontario. These are geologically young glacial lakes that hold about 20% of the world's fresh water. NOAA monitors the water properties of these Great Lakes using buoys, ships, and satellites. All measurements indicate the Great Lakes of North America are warming. In one study, 27 years of buoy data from 1979 to 2006 showed that Lake Superior, the deepest Great Lake, warmed more than 4 degrees Fahrenheit. 50 years of model data covering the time period from 1963 to 2013 from NOAA's Great Lakes Environmental Research Laboratory indicates Lake Superior has warmed more than 6 degrees Fahrenheit. Trends from the model match closely to that of satellite observations collected over the past decade. There are 3 main reasons our lakes are warming: shorter and milder winters, less lake ice, and early stratification dates. Every lake has a thermal stratification profile. Here's how it works. In summer, solar energy heats the upper layers of the lake, causing warm waters to float on the top and stratify above the significantly cooler waters at the bottom of the lake. During autumn, the upper surface layer cools through energy exchanges with the atmosphere. As the water cools, it becomes more dense, sinks, and is replaced by colder waters from below. Commonly called turnover, this mechanism provides important mixing of nutrients, minerals, and oxygen throughout the depth of the lake. During winter, the lake cools to a fairly consistent temperature from top to bottom. However, a slight stratification persists with less dense water freezing to ice at 0 degrees Celsius along the surface temperatures, remaining as mild as 4 degrees Celsius along the bottom of the lake. Spring turnover occurs when the lake ice melts, setting the stage for summer stratification again. In the mid-latitudes, where the North American Great Lakes are located, warmer winters with less lake ice are causing earlier spring turnover and earlier summer stratification, so surface waters can warm sooner and longer. This is making the biggest difference for deep lakes like Lake Superior. Another cause for concern with warmer lakes is increased algae production. Algae are naturally occurring organisms that grow in water. Most algal blooms are harmless, but certain types of algae pose a risk to humans, animals, water quality, and ecosystems. A harmful algal bloom, or HAB, is a bloom of blue-green algae that potentially contains toxins. HABs can cause fish kills, foul up beaches, and produce dangerous swimming conditions. To protect people and ecosystems, NOAA has joined NASA, the Environmental Protection Agency, and the U.S. Geological Survey to design an early warning system for toxic algal blooms in freshwater lakes. This project will leverage satellite data with mobile technology to provide health advisories and improve our understanding of harmful algal blooms, which is increasingly important in a world with warming lakes.